Hello, welcome. Thank you for your attention, so on and so forth. Median and altitudes of triangles is our next subject. Today you will identify, or I will identify, and use medians and altitudes of triangles. So we need to basically understand definitions here and understand what is a median, what's an altitude. So, first off, let's talk about a median. I'm going to back this up just a wee bit, okay? Yeah, we'll go right here. Okay, so the median of a triangle is a segment, with endpoints being a vertex of a triangle and the midpoint of the opposite side. So if you basically take a line that goes straight from the vertex, notice this is not, and we'll look at the chart at the end. Starts at the vertex, goes to the other side. We'll call that point D. But that point D is the midpoint of AB. Okay, such that, obviously AD and DB would be equal. Then that means that is what is called a median. Notice this one is only a segment. It can only be a segment. It's not a line, it's just a segment, so it will stop. So basically it will divide the triangle into two more triangles. Keep in mind, every triangle will have three medians. One through, like, say, A, starting at A, one starting at B, one starting at C. Oh, which I think I'm about to show. Oh, look, like that. So every triangle has three medians. Okay? That would divide each side of the triangle into two equal segments. Okay, that line, or that point, because those three medians will intersect at one point. That point of concurrency is called an centroid. And the centroid is always inside the triangle. So kind of make sure you remember that. So that one will be called a centroid. Okay, and there is a centroid theorem. Centroid theorem states that basically the median from the vertex to the centroid point is 2/3 of the total distance from the median segment. Okay? So in other words, like here, notice that AP is 2/3 of the distance of AK. There's also another part there that you should be able to come about, saying like that PK would be 1/3, but we'll talk about that in a little bit. Anyways, here's an example. Went too far. Hold up. Alright. Okay, so in triangle ABC, Q is the centroid and BE is equal to 9. Find BQ and QE. Okay, so BE is 9, so that's the whole line, but they want us to find BQ, which is 2/3 of BE. In other words, it's 2/3 of 9, which you could easily do in the calculator, but it's basically 9 times 2 is 18. 18 divided by 3 is 6. Okay, so if that one is that, then I could easily say, okay, BQ plus QE is equal to BE. So 6 plus 9, so QE is equal to 3. Notice there is a relationship between these two, okay? Between BQ and QE also. And kind of see that answer right there. And then look at the next answer, and I think that will help kind of explain things a bit. Okay, so let's change this up. So notice that all I did there was change that up a little bit. Find FQ and QC. Now, I'll make note of this. In the book, they put that as find FQ first and then QC. Well, how would you do that? Well, let's look at this. Okay, so we're going to make sure, again, QC is 2/3 of FC. Because remember, it's from the vertex to the centroid point. Okay, so it's 2/3 of 15. 2/3 of 15 is 10. Okay, so if that is 10, and the whole thing was 15, then obviously the last part, this little part right here, is 5. Now, notice again, something about those two. How this one is half of this one, or basically if you find the smaller length, double it, you've got the longer length. Because if it's 1/3, if the other one's 2/3, then that one's 1/3. Alright, so let's look at this one. In triangle J, K, and L, we now know PT is equal to 2. Okay, so if you notice here, because all 3 points, the R, the S, and the T, are midpoints, then that means P has got to be a centroid, because they're all part of segments that go to their vertexes. Alright, so since we now know P is a centroid, we now know that KT is equal to KP plus PT, and we know KP is 2/3 of KT, and that's 2/3, then guess what? PT has to be 1/3. Okay, so if I know this, notice here that 1/3, 2/3, 2/3 is double of 1/3. So if PT is 2, then KP has to be 4. Okay, kind of a simple thing to understand there. It shouldn't be too hard. All right. All polygons have a balance point or a centroid. So the centroid is actually a balance point. In a triangular region, the centroid is the center of gravity, the balancing point. In other words, if you like had a real object and like we're just trying to like make sure you could hold it up steady, if you find that centroid point, then that would keep it properly balanced and be the most stable part to keep it from falling over. Okie dokie, so let's look at an altitude. An altitude of a triangle is a segment from the vertex of the line containing the opposite side line. It's like the height of a triangle, okay? But we call it an altitude. Now, I'm going to back this up just a wee bit. Okay, so notice here, okay, or not. Okay, if I have a, like, say, this is an acute triangle, then notice that that one will go, basically it's a line that goes straight down. Now, and it would make a 90-degree angle. It doesn't have to divide it in equal halves, but it goes straight down, making a 90-degree angle, and that's kind of considered the height of the triangle. If you have an obtuse triangle, notice how that altitude will be on the outside of that, and like this, if you kind of see here, it's almost like it's making a big right triangle. Okay? So anyways, that's the altitude. Now, again, every triangle has 3 altitudes, so depending on where you're looking at it from, you would see 3 different altitudes. Okay, so what is an altitude? So is there a point of concurrency there? Of course there is, and that's called an orthocenter. Nothing special about that other than, again, those would be the 3 altitudes, and kind of go from there. Now, we've introduced kind of a lot of points here, so we need to make sure that we understand what those points are. Okay, so we've talked about perpendicular bisectors, angle bisectors, medians, and altitudes. And all of them have points of concurrency, a circumcenter, an incenter, a centroid, and orthocenter. So you need to make sure you understand how and when and which one you're using. Okay, so kind of keep that in mind. Make sure, I would probably have this chart ready to be used. Maybe have a little bit of self-explanation there to help you when you're using that for the test, and kind of go from there. Anyways, that will be it for today. Thank you so much for your time. Y'all take care.